24/7 mission critical applications. I'd like to mention a little bit about the meetup group, how it all started. It started like 6 or 7 months ago in July last year. Out of enthusiasm, we were working on Apache Kafka solution for the rail bank in Utrecht, and we were really enthusiastic about the stuff we were working on. So we just wanted to transfer this enthusiasm to other people. We were sure that probably some other people in Holland were working on cool Kafka solutions, and apparently there are. So that's the reason why we are now here at Eneco. So as I said, the first meetup outside of Utrecht, and as I said, we want to keep facilitating, and I think we have another meetup coming in 2 months, probably. I see a person nodding over there, so the next one will be probably in Amsterdam. So I made a little graph of the Kafkaians. That's what I name all the people in the Kafka meetup group. Started in July last year. The last, how do you say it, curve in the graph was when it was announced that Jay Kreps was coming. So you see a slide been upwards. And I made a little prediction for May. We will be around 200 people. And if we go on like this, next year in January we will have around 300 people, and we need a slightly bigger room. So, now first let me introduce to you Jay Kreps. Probably if he wasn't started on working on Apache Kafka, we wouldn't be here. So it's really great to have him here. If I'm correct, you started working on Apache Kafka in 2011, around that year? A little earlier, okay. So maybe you can mention it a bit later. So he's the co-founder and CEO of Confluent, and co-creator of Kafka. He was the lead architect for data infrastructure at LinkedIn, and he's among the original authors of several open source projects, including Project Voldemort, Apache Kafka, and Apache Sansa. And he will be talking about distributed stream processing with Apache Kafka. So give it up for Jay.
Thanks for coming. Okay, so my plan was to talk about the Streams API in Kafka. I can also do kind of more an introduction to Kafka. I can do whatever is useful. So just a show of hands, how many people are already pretty familiar with Kafka? Is that lots of people, some people? Seems like a lot of people. So would an overview of the Streams API be a useful talk to do? I want to make sure I'm so I'm going to be talking a little bit about distributed stream processing with Apache Kafka. This is going to be an overview of the Streams API in Kafka. I'll talk a little bit about why we made it, how it fits into the kind of the wild world of stream processing, what you can do with it, and so hopefully it'll be a good introduction. But before we get to that, let me start and talk just about what stream processing is. So, what I mean by stream processing isn't necessarily what people think. Right? So I'm going to talk about processing streams of data out of Kafka. What I don't necessarily mean by stream processing is something that's, transient or lossy or approximate or just about calculating analytics very quickly and then losing everything. What I actually mean is something that's, kind of a third paradigm for programming. So when you think about writing a computer program, a lot about that program is really driven by how you get your data, how you get your inputs and how you get your outputs. And the two ways that most programs are written are they're either a request-response program, like a web service, maybe a OLTP database works this way, or maybe they're a batch program, right? So if you had a computer science education, maybe the first program you wrote was one that kind of read in a file and did something to all the lines and printed out the results, right? It's kind of the batch process. Maybe the modern incarnation of this is Hadoop, where you can run big distributed programs on big distributed files. To me, stream processing is really kind of a third paradigm, which actually kind of generalizes both of these. So, it's actually not something that's a more limited form, but maybe something that's a generalization, more powerful than both. And to kind of explain what I mean by that, let me start and just explain a little bit more about each of these paradigms. So for request response, what you're getting is you're getting one input, the request, and you're giving out one output, the response, right? And for every input, there's always one output. You can't have like 4 requests that lead to 1 response. And it's always, if you write a service like this that takes requests, it's always about the future requests and responses. On the other hand, batch is kind of the opposite of this, right? You collect all the inputs, and then you run a big program on it, and you produce all the outputs. And so it's a little bit like these kind of old mainframe jobs, but a lot of the world still runs on this stuff. And batch processing is a little different from request-response processing in that it kind of works only on past data. Like if you make a service, it comes up, it takes new requests. If you make a batch process, it really only processes the data that's already been written to the table, or the data that's already been stored in the file. And so it's a little bit different in that way. Stream processing is actually kind of unifying both of these. So you're able now to react to a stream of events. You're able to take any number of these events you want. You can take one, you can take many, and you produce output kind of at the cadence you want. And so this is more general in that way. It's also going to unify processing past data that's stored in a stream with new data that arrives as it arrives. And so it's more general in that way as well. And that's kind of what makes it so powerful. So what does this mean in practice? Well, in practice, I think you have to think about almost how it fits into solving real problems, right? What kinds of problems is this applicable to? And so I'll give some examples from a domain that probably most people understand, which is retail. So most people probably understand retail. If there's a chain of retail stores, they have to have products. They have to get products into all the stores. They have to order new products. They have to sell the products and take money. They have to manage their inventory, all that kind of stuff. And you can kind of think of a lot of this as being a type of stream processing problem. It kind of naturally happens. You might make these sales in a kind of interactive walking request response way. But a lot of the mechanics of running a retail business, you are reordering products as your inventory runs low. You're migrating products between maybe distribution centers or locations to keep stock. You're keeping track of your inventory. You're adjusting prices as you sell more or less. All of these are these kind of continuous processes. Now, you might implement it to only run periodically, but inherently it's something the business does over and over again as it progresses. And so, I think that this is common for a lot of businesses. When you look at problems, a lot of problems that's connecting cars and collecting streams of data. A lot of these processes actually kind of react to the data that occurs, process continually. That's kind of a natural way of modeling. And so how does that relate to Kafka? Well, it turns out Kafka is also built for streams of data. And I'll introduce this API for doing stream processing on Kafka. So I'll give a quick introduction to Kafka for anyone who kind of showed up and this is their first exposure. So, the fundamental abstraction in Kafka is this idea of a log. So a sequence of records that are appended by some writer or some many writers. And you can think of this as being, like the actual physical instantiation of a stream. When you talk about processing a stream, this is literally a stream. We look at a stream being written across it. In this picture, each of these rectangles is meant to be a record. And each of the records gets a unique offset, which is its position in the log. It's the position in the stream. It's kind of like the time that that record was written or occurred. And you can have any number of readers that read on this log. So this data structure will turn out to be really fundamental for stream processing and really fundamental for Kafka. And it turns out that these logs are a really good implementation for publish, subscribe messaging, but they also help to unify this area of stream processing. So, a log is storing all the past records that have been published, but it's also allowing you to subscribe and read future ones that arrive. So if you build a program that processes against a log, it can kind of churn through past data, and then as new data arrives, it can kind of keep going and update itself. And so this is kind of a powerful way to think about new data as being in this kind of linear log, so that you can process it as both as it arrives and in the past. And this model applies not just to data that's kind of events, right? So if somebody clicked on this, that's clearly an event. You can publish that to a pub subsystem like Kafka, and you can subscribe to it. You can process it as a stream. It also applies to mutable data, like the data you have in a database, to like data that's in tables. And so a common use for Kafka, this is actually replicating the changes out of a database. So publishing the stream of updates to records. So maybe you have a table which stores information about your customers, and you might publish out the newest version of that customer record every time it's updated. And that might allow other systems to get a hold of a copy of that data and keep it up to date in themselves. So, this is commonly done internally in databases to keep replica databases. But one of the nice things about Kafka is it makes it possible to do this across systems. So you can have this kind of change log that's published out of your database that would feed search index, maybe an Elasticsearch, or might feed some kind of cache in Redis, right? And Kafka has special support for this type of mutable data, right? It has an idea of a compacted topic, which allows it to retain just the latest update for each type of mutation by key. And that turns out to be a really key feature as you try and support this. And that log compaction feature allows you to take a series of updates, and instead of just throwing away the oldest, it allows you to come back down to kind of the latest state. And this will turn out to be important as we get into stream processing. I'll talk a little bit about why. But the final kind of abstraction in Kafka is this idea of groups, of consumer groups. And Kafka has a facility to keep track of a set of processes and figure out which are live and balance the load over those processes. And this turns out to be really fundamental. This is how you scale out the consumption or processing of data, and this will turn out to be really important for stream processing. So this allows you to keep track of a set of processes that are dividing up your data. So maybe if I have a topic in Kafka, and maybe that topic has some feed of data, I can have a group of processes labeled A, and that data is divided up amongst the A processes. And I could have a group of processes labeled B, and that data would be divided up also among the B processes. And these groups are fault tolerant and elastic. So if a new process that's part of A comes, it will get some of the data. If one dies, it will take over. And so those who are familiar with Kafka probably all know all this. This is just kind of the basics of Kafka. But when you put these basics together, with the vision we really have for how this comes together, is as a type of streaming platform. So something where many systems can publish streams of data. You can have applications that publish streams of events. You can capture changes from databases. And And you can do this either to serve a single application, or you can do it at really large scale across the entire company and unify a lot of your data that way. And so what I'm going to be talking about is really the stream processing or application development, how those plug into this, because that's part of this overall picture. So when you talk now about using these, using Kafka for stream processing, we've created this new Streams API. We kind of had, a motivation to try and make it easier. And the reason for that was we saw kind of two approaches that people were building applications around Kafka that would feed off streams and do processing. And I'll go through both of those approaches. So the first approach was really simple. Basically, they would just use Kafka kind of like a messaging system, and they would write an application, and it would feed off of Kafka. And so I come from the San Francisco Bay Area. In San Francisco, they have a lot of hipsters. I don't know if there's a lot of hipsters here. I don't know if that's like a common phrase, but hipsters like the kind of more primitive version of everything. So instead of a laptop, you might have like a typewriter. And you can kind of make fun of it, but old technology is kind of reliable, right? It's like simple, it works every time. So the bikes in San Francisco, they're all fixie bikes, they only have one gear, right? Which works great, except in San Francisco it's all hills. So once you get to a hill, it's a little bit difficult. So what does this have to do with stream processing? Well, this architecture, just basically using the producer and controller to do transformations on data, it's kind of simple and powerful and beautiful, right? You build your app, you subscribe to some feeds of data, maybe you write some stuff back. It's not very complicated or invasive. You have to figure out how to get Kafka set up, but you don't need a lot of other infrastructure that's going to kind of take over and dominate your life to build some kind of thing which processes streams. But it's a little bit like the fixie bicycle, right? It works really well until you eventually get to a hill, and then it's hard to pedal. So, in stream processing, there are some hard parts. And so if you kind of just use this lower level messaging API and you just send and receive a message, there are some hard parts to start to run into, and you have to figure out how to handle that, right? So if you just process a single message out of a box, maybe there's not too much to do. But as you start to think about more than one message, you start to think about the state that you're maintaining in your application, and when is it going into output, and what's the semantics if your process fails. How are you going to partition and scale it out? What happens if you need to change your code that's processing results and go back and reprocess results? And you can usually come up with solutions to some of these problems, but it's not easy to do, and it's not easy to do it well. And so that's kind of the downside of that simplistic approach. On the other hand, the thing we saw people do was there's a whole set of kind of frameworks that you can use. You can build out a cluster, and they help you do stream processing, and they work with Kafka, so you can use that to build stream processing applications. And so that would be things like Spark Streaming or Storm. Samza was one that helped develop at LinkedIn. Flink is a newer one that's quite good. And these systems are actually quite nice. But they tend to have a slightly different focus than what we saw people often trying to do with these simple applications they were building. So they tend to look almost like an outgrowth of MapReduce, right? Where you're, writing some thing and you're kind of deploying it into a cluster, and it tries to put it on certain machines, and so they might run on top of Yarn or something like that. And it's a little bit heavyweight for the type of application development that we saw people trying to do. And it's a little bit complicated to get set up because you have to kind of build out this whole cluster and figure out how to monitor your application across all the parts of it. So that was really the problem. There's just lots of moving parts to keep going. So here's kind of an example architecture. I basically redrew this from something somebody showed me, which is you would have Kafka, and then you would kind of set up one of these stream processing frameworks like Storm or something, and you kind of deploy your code into that, and you have to implement your code. And then if you want to do anything which spans multiple records, like you want to count records or sum records or join data on, maybe you need a side database for lookups, and then maybe you produce some output which goes into some kind of data store, and then your app could serve requests against that. But if you want to go back and reprocess data, you might go through some batch systems to do that. You might have to re-implement your code. hard to make something mainstream if it's complicated, I think. And so I think for us, the goal is to try and make stream processing as simple as possible. If we think the mainstream way of building applications, it should be really easy to build applications. And we really found that the hard part of distributed systems is really operations, really building things that work well, right? So the coding is maybe difficult, and the debugging is usually a little harder, but it's really the operations of the resulting system that's the most difficult part. And so we thought there might be a better way to do this, and this was our motivation for the Streams API. So what is Streams? It's one of the newest clients for Kafka. So Kafka has a producer, it has a consumer, it has a connect API, which allows you to build connectors or integrations to other systems. And it has a Streams API. And all that this client is really a client. It's just a simple library like the producer or consumer that you can use in your application. We only have a Java version of it so far. But despite being kind of a humble library, it's actually quite sophisticated as a stream processing framework. So it'll allow you to do sophisticated windowing, it supports reprocessing, it produces records immediately, and it'll allow you to do stateful processing. And so in comparison to some of these other frameworks that are out there, I think it's basically enabling a lot of the things these stream processing frameworks did. But it actually allows you to be much simpler, right? So you kind of get the same power, but without the cost in your application development, and especially in your operations. So it's really not much more complicated than a Kafka consumer, but it gives a lot more functionality in your application. So I'll show actually a complete Kafka Streams app here. This is Java code, so it's not that short, but it's still pretty short. So what is this? It's just a main method in Java, right? And so you just run this, by typing Java in the name of the class. And what it does is the first little section is kind of configuring the job and telling you where to find the actual Kafka cluster. Then you kind of telling it how to deserialize the data. And then here you have logic that actually does processing. And what is this doing? Well, this example is doing like a continuous word count. So it's actually subscribing to a stream of documents. It's splitting those documents up by word, and it's counting the number of occurrences of each word. This is not